Hey everyone, I hope you are ready for round 2 in the world of integers. Today we are going to use an integer's position on a number line to determine its overall value. We're going to start with an example. Take a look at the one on your screen, grab a sheet of paper, make sure you work through this problem with me. The example says, the table shows the low temperatures during a cold week. Find the day that had the lowest temperature, then order the temperatures from least to greatest. And in our table, Monday had a temperature of 3 degrees Celsius, Tuesday, negative 6 degrees Celsius, Wednesday, 5 degrees Celsius, Thursday, 1 degree Celsius, and Friday, negative 5 degrees Celsius. One way to compare the values of integers is to create a number line and plot those integers on the number line because their overall position will determine their value. So I want everyone on your sheet of paper, create your own blank number line with a 0 in the middle, and let's fill it out. So if 0 is located at this tick mark on my number line, the positive integers would be to the right of 0. So the first integer to the right of 0 would be positive 1, followed by positive 2, positive 3, and positive 4. Coming back to 0, moving to the left, the negative integers would be to the left of 0. So the very first tick mark to the left of 0 would be negative 1. Next would be negative 2, negative 3, negative 4, negative 5, and negative 6. Please pause the video if you haven't already made your number line. Recreate the same number line we have here, and then start playing the video again, and we'll complete the rest of this problem. Hopefully you have created your own number line looking like mine, and we're going to use it to plot the values from the table. Starting with Monday. Monday had a low temperature of 3 degrees Celsius, so we're going to go positive 3 means 3 units to the right of 0. We're going to plot a point on positive 3, and we'll label it M for Monday. Our next temperature is Tuesday, had a low temperature of negative 6 degrees Celsius. So to plot negative 6, we start at 0, and we're moving 6 units to the left and plotting a point at negative 6. Label it T for Tuesday. Next, we have Wednesday, a temperature of 5 degrees Celsius. Positive 5 is found 5 degrees to the right of 0. So I actually need to make an extra tick mark here for positive 5. Wednesday is at positive 5. Thursday, 1 degree Celsius, that is 1 unit to the right because it is positive. We'll go TH for Thursday. Plot that point, please. And then finally, Friday is negative 5 degrees Celsius. That means 5 units to the left. And label that F for Friday. So now that we have the positions of all the low temperatures for each day of the week, let's answer the questions being asked. If we go back to the original problem, the problem asks us first to find the lowest temperature. So the lowest temperature would be the integer with the least value. And on a number line, the further to the left, the lesser the value. So which point was furthest to the left? That was Tuesday at negative 6. So the coldest temperature was Tuesday. The second part of this problem asks us to list the temperature values from least to greatest. So we've already determined that the coldest temperature or the least value was on Tuesday. Well, as I work to the right on my number line, the further right I travel, the greater the value of the integer. So moving from left, which is the least value Tuesday, to the right for my increasing values, Friday would be the next coldest at negative 5 degrees Celsius. And then we continue to move to the right. The next day I run into is Thursday, which had a temperature of positive 1 degree Celsius. Next would be Monday at 3 degrees Celsius. And then the warmest day, Wednesday, at 5 degrees Celsius. So the temperatures from coldest to warmest or least to greatest was Tuesday, Friday, Thursday, Monday, Wednesday. All right, the next type of example I want to talk about is just comparing values of integers using a less than, greater than, or equal to sign. So our first two integers to compare are 5 and negative 13. To think about their value, think about their position on the number line. The number that is further to the right has a greater value than the other number, or the number that is further left on the number line would have a lesser value. So positive 5 and negative 13. Positive 5 on a number line, if I made a number line, 0 would be here, positive 5 would be to the right, and then negative 13 would be way to the left. Because 5 is further to the right than negative 13, it has a greater value. Next comparison, negative 11 and negative 18. Again, if you made a number line, here's 0, negative 11 would be 11 units to the left, and then negative 18 would be even further left. So because negative 11 is further to the right than negative 18, it has a greater value. Negative 11 is greater than negative 18. Next, 8 and the absolute value of negative 8. In this scenario, we actually need to calculate the absolute value of negative 8. Remember, absolute value means the distance of an integer from 0. So how far away from 0 is negative 8? Well, it is 8 units away because the absolute value of negative 8 is 8. So how does positive 8, compare to positive 8? They are equal. So 8 is equal to the absolute value of negative 8. All right, I have 6 comparisons for you to try on your own. Copy them down, pause the video, work them out on your own, compare their values using less than, greater than, or equal to. When you're done, begin playing the video again to check to see how you did. Okay, number 1, we're comparing negative 4 and 0. Negative 4 is further left than 0 on the number line, so it is less than. Negative 21 and negative 22. Negative 21 is greater than negative 22 because it is further to the right. Absolute value of 22 is 22, and the absolute value of negative 15 is 15. So we are comparing 22 to 15. 22 is greater than 15. Next, 2 and negative 1. 2 is further to the right than negative 1, so it is greater than. The absolute value of 9 is 9. The absolute value of negative 9 is 9. Those values are equivalent, so the absolute value of 9 is equal to the absolute value of negative 9. And finally, comparing negative 54 to negative 1. Negative 54 is much further to the left of 0 than negative 1, so it is less than. Okay, final example of the lesson. We are given a set of numbers, and we need to order them, in this case, from least to greatest. So the values we are given are negative 6, 5, 7, the absolute value of negative 15, and negative 12. Before I can order any of these values, I need to perform any calculations that need to take place. Negative 6 is already simplified. 5 is good to go. 7 is good to go, but I have some work here with the absolute value of negative 15. Negative 15 is 15 units from 0, so the absolute value of negative 15 is 15, and then negative 12 is already good to go. Remember, I am working from least to greatest, so I want the least value of these 5 integers. The integer with the least value would be furthest left on a number line. So if I look here, negative 12 is the least value because it would be furthest left. Next would be negative 6, followed by 5, and then 7. And then the greatest value here was 15, but it was originally written the absolute value of negative 15. So from least to greatest, negative 12, negative 6, 5, 7, and the absolute value of negative 15. All right, here's a problem for you to try on your own. We are ordering these numbers from greatest to least, 8, -6, -2, the absolute value of 3, -3, and the absolute value of -11. Go ahead and pause the video, complete this problem on your own. When you are finished, begin playing the video again to check to see how you did. Okay, here we go. Let's check to see how you did. First, simplifying all these values. 8 is good to go. -6 is good. -2 is good. We need to calculate the absolute value of 3. That has a value of 3 because 3 is 3 units from 0. -3 is fine, but we need the absolute value of -11. That works out to +11. Now, tricky part to this problem, make sure you read the directions. We are going greatest to least. So to find the greatest value, I need the integer that would be furthest right on the number line. And that's going to be 11, originally written as the absolute value of -11. Next, working our way from greatest to least means we're going from right and working our way left on the number line. So the next greatest value would be +8, followed by 3, which is written as the absolute value of 3. And then we would have -2, -3, and the least value of this set, -6. Go ahead and make sure you complete the independent practice for comparing and ordering integers. Take a picture of your work and upload that file for submission. Take care, you guys.